In this lesson, we'll just do a quick overview of some key ideas about the periodic table that will help us to identify the ions, the common ions of metals and nonmetals. This is a really important skill for being able to write formulas of ionic compounds. The first thing to be able to identify is whether or not an element is a metal or a nonmetal. So using the periodic table and the location of the elements on the periodic table, we can identify this classification. We have the staircase that is in purple here, and those represent our metalloids. And as you know from previous courses, those have properties that sort of bridge. They have some properties that are metallic and some properties that are non-metallic. To the right of the staircase, we have our nonmetals. So any element that is yellow in this section here is a nonmetal. And so those will exhibit the properties of nonmetals. They won't be conductive, etc. On the left-hand side of the staircase are our metals. Okay, so they're labeled in blue in this particular periodic table. And the one exception here is that hydrogen is to the left of the staircase, but it is a nonmetal. It's positioned there in the periodic table for other reasons, which we will learn about as we move through this course. But for now, it's just important to recognize when you are identifying or classifying hydrogen that you classify it as a nonmetal. This table here shows you the common ions of many of the elements in the periodic table. And it's important for you to know the pattern that has arisen here. So with group 1 elements, the charge is +1. With group 2 elements, the charge of all of these elements when they form their common ion is 2+. We're going to skip over the transition metals for now, and group 13 elements tend to have a 3+ charge. Carbon is listed here. Group 14 is listed as having a 4- charge. That's a rare form of finding carbon. You'll learn more as you study that carbon actually tends to not participate in very many ionic compounds. And so this ion is not that common, but if it were to form an ion, it would be 4-. Our group 15 elements are 3-. Group 16 are 2-, and our halogens are group 17 are 1-. So we can look at the pattern here. So noble gases don't tend to form ions. And so when we go to the left, it's almost like you're looking at a number line. When we go to the left from the noble gases, we have -1, -2, and -3. And then when we go to the right of the noble gases, we have 1+, 2+, and 3+. So it is important to be able to identify quickly using the periodic table the charges on the ions. We will talk about in a later video the transition metals and some of them being multivalent or having more than one possible charge. For now, you just want to be able to identify these ones that we've looked at so far. And just to give a little bit of a background to remind you where this came from, when we look at the Bohr diagrams for these elements, elements that are in the same group have the same number of valence electrons. So it makes sense that they'll also form the same common ion. So for group 1 elements, they all have 1 valence electron, and they will tend to lose that electron when they form ionic compounds. Whereas our group 6, or oxygen and sulfur, they have 6 valence electrons, and they'll tend to gain 2 electrons, which have a negative charge, and that's why they're left with a 2- charge as their ion. So at this stage, because we're not focused on the atomic structure and the theory, you're not going to necessarily need to be able to dive deep into explaining why they form the ions that they do. Okay, we will look at that in more detail in a different part of the course. Okay, for now, it's really just important that you feel comfortable identifying the ions based on the position that an element has on the periodic table. So for example, by inspection, in this example, I have calcium. Calcium is an alkaline earth metal, which is in group 2. And when I look at my pattern, I know that it's 1 plus and 2 plus. So therefore, the common ion that calcium will form is calcium 2 plus. Whereas potassium, which is just to the left of that, will form a positive ion with a 1 plus charge. For nitrogen, okay, based on its position here, I know this is 1 minus, 2 minus, and 3 minus. So my nitrogen is going to have a 3 minus charge. Whereas aluminum, based on its position, is going to be 3 plus. And finally, chlorine is going to have a 1 minus charge. Now, a question that comes up often is, why do we write it as 3 plus and not plus 3? And it's because later in chemistry, we learn about something that's called oxidation numbers. And when we identify the oxidation number, we refer to it as plus 3. Okay, so a couple of times I went back and forth, but at this stage, when you're looking at the charge of the ion, you really want to say the number and then the positive or negative after that. Okay, I hope this helps. It's a really important skill to be able to determine the ions on a compound. So be sure to ask if you need help.